Okay, this is some notes on chemical reactions, and these are types of chemical reactions. There are 5 main types of reactions that we are going to look at. Unfortunately for you, some of them have more than one name, so that makes it a little bit more difficult. But hey, vocabulary, right? So starting off, we have combustion or synthesis, and this is when we are taking reactants, small reactants, and we stick them together to make a bigger product. Or and this is characteristic of having maybe only one product on the right side of the equation and a couple of reactants on the left side. So a couple of examples that we have for you to look at. First off, we have Na and Cl will give us NaCl, and I do want you to fill those in on your sheet. The other examples, this is the photosynthesis example. You have carbon dioxide and water will make a sugar, and oxygen. This is very important to us because plants do this and we breathe this in, we breathe this out. So basically plants are doing the opposite of breathing that we do, but they also make yummy sugar while they are doing this. And then our last example that I've kind of squiggled all over would be lithium and borine combining to make lithium bromide. As you can see, we, in this first example and the third example, we've made one product. We've made fewer products from more reactants. In the second one here, we still have 2 reactants and 2 products, but this sugar is very complex. So it takes quite a bit of energy to build up C6H12O6. Okay, so moving on to our second set is decomposition, and this is basically flip of a combination reaction. So we're just breaking down instead of building up. So you have your decomposition. More complex reactants break down to make fewer, or to make simpler products. And if you notice, I have a simple base formula. AB breaks up into A plus B. This is just a base. There are no elements A, B, C, D, and so on. This is just kind of to help you reference that. So in here we have our NaCl breaking apart to Na and Cl, our sugar breaking apart to carbon dioxide and water, and our lithium bromide breaking up into lithium and bromine. So again, this is just the flip of that combination reaction. So what I really want you to write out here, and your space is a little bit bigger in this area here, is what is the relationship between the synthesis and decomposition reactions? They are opposite of each other. Write that down. They are opposite. In a synthesis or combination reaction, we are building a product. In decomposition, we are taking that piece and breaking it apart. So these two are really opposites of each other. Sometimes these will run together. So we can have reactions that take the reactants and they build a product, and if we don't grab that product fast enough, it'll break apart and go back to the reactants and do a decomposition the other way. So we see that these reactions go both ways. Okay, looking at number 3, we have a single replacement reaction. Single replacement. So if we look at the base formula, we have A plus BC, and we notice that A comes and kicks BC off, or B off, and then A and C get to be together, and B is the one that is ousted. So in our example, we have iron, and it comes into contact with copper chloride. Well, the iron will kick the copper off, and become iron chloride, and copper is just kind of floating around. In the second reaction, we have Na kicking off and hydrogen from water, and we make H2 and sodium hydroxide, which is a strong base, and we'll get into that later, but this happens very readily, and we have to be extra careful when we are playing around with this. We have nickel will remove the hydrogen and become nickel chloride, and we have fluorine, which will remove the oxygen this time, producing an oxygen gas and a hydrogen fluorine. This one looks like it would be very useful because we make oxygen and we like oxygen to breathe, but the hydrogen fluoride that's produced is very toxic. It's pretty nasty stuff. So if we were running out of oxygen, I would not suggest using this reaction to get it, because you're going to have a pretty nasty product on the side. Okay, double replacement. See, we're almost done. We're on number 4. You can do this. Double replacement is similar to the single replacement, but we switch 2 of them. If we look at our base, we have AB and CD. We have the A is going to jump over and hang out with D, and the C is going to jump over and hang out with the B. So we have AD and BC. So A and C have swapped places. There were 2 replacement reactions going on there. I'm going to get rid of this little arrow so that way we can see this reaction beneath. Okay, so I've tried to, in my notes, bold these so you can see them a little bit better, but we have the Ca and the Ag. They're going to swap places. So originally Ca was paired with the Cl2, and then if you notice, as a product, Ag is now paired with Cl, and Ca has buddied up with the NO3. So we have swapped places there. Same thing in the next reaction. We have Na2 and Ba. They're going to swap, and then the Pb and the Li are going to swap. Now, you could look at this and see that maybe Cl and NO3 were swapping places, and the Ca and Ag were staying where they are. Either way you look at it, we are taking 2 things that are trading places. Okay. And our last one that we are going to look at, we are going to look at combustion. And this is the fun one. This is the one that you guys all want to do all the time. This is the explosions. Yes, we love explosions. We want to blow things up. Always, always, always. So explosions, fire, that is a combustion reaction going on. And if we look at the base formula, you have some fuel source. So usually that fuel source contains hydrogen. Not always, but it usually contains hydrogen. It is very important to notice that for a combustion reaction we have to have oxygen, because we are going to make a gas with that oxygen, and every single time you have a combustion reaction you produce water, heat, and light. Now the heat and light, that's the fire. Okay. This water, it doesn't look like we would make water when we combust something, you know, like that kind of seems a little ridiculous because water puts out fires, but it's a very small amount of water, and it's usually in a gas form because of the amount of heat. We've already made the water into a gas state. So looking here, we have methane, CH4, and when we put that in the presence of oxygen, we can make carbon dioxide and water. This is what's going on when you burn natural gas, or in our classroom, like when we use the Bunsen burners and light stuff on fire. We are doing this. Propane, if you have a grill, will react. And if you notice, we are still making CO2. It's the same thing, as the product that we made with methane, but this time we were able to make 3 carbon dioxide instead of just the 1. Now, in our third example, we're using magnesium. We don't have this and this carbon and hydrogen mix, but it still will make it still will make a product. We're still involving oxygen. Energy is released, so we call it combustion. We can also call this a synthesis reaction because you're taking 2 reactants and you're making a bigger product. Same thing going on with iron. If we mix that with oxygen, you can make iron oxide. Again, that could be classified as combustion or synthesis. This one here, we did in class. This was the one that we had the little clear, or the little ceramic dish, and it was glowing. You saw that, those glowing happening. That's what was happening when we were making the magnesium oxide. So we were doing a combustion reaction. Okay, what I would like you to do now, I would like you to go back to worksheet 2 that we had finished, and I want you to identify each of the problems as a single replacement, double replacement, decomposition, synthesis or combination, or combustion. Label them of the 5. There are 4 of them that do not fit the pattern. So don't do it to 11, 12, 17, and 20, but do it to the rest of them and just put it out in the margin. Okay, so that's part of your assignment. There will be a spot on Canvas called Worksheet 2 IDs. Okay, so if you didn't do these notes, you won't know what your assignment is and what to turn in on there. So it's kind of a little double check on my part, but I do want you to practice identifying these on the worksheet 2.